Okay, let's see. Okay, let's see. Okay, guys, can you see a screen of our on-course page right now? Okay, thank you. Okay, so let's see what's going on here. All right, I just want to pull this up so that we can walk through some things together. So the main purpose of today's meeting is that I want to go over how to calculate standard deviation and variance. But first, I wanted to see if you guys had any questions about the first part for the assignment on descriptive statistics. So I just want to make sure everyone was clear that the data that we're using is this 36 country data. I posted it as a Word page and an Excel sheet just in case people couldn't open up one or the other. And then there's the code book as well in case you need any explanations. So the first part is just looking at that data and calculating doing a frequency distribution and doing measures of central tendency using the data from that data set. Does anyone have any questions about that first assignment? Okay, so we'll move on from there. Just reach out if you have any questions, but hopefully that was pretty self-explanatory how to do the frequency distribution table, and also just working on ratios, percentages, of course, coming from the frequency distribution, and then measures of central tendency, mean, median, and mode. So what I want to move on and talk about today, and interrupt at any point with questions, but I want to talk about measures of variability. So of course it's very interesting to look at what the middle of our data looks like, but now we're going to get a little more sophisticated and see, you know, how does the data vary around that middle? So we sometimes call these measures of dispersion. How is your data dispersed? Measures of variability, again, how does your data vary? So I'm going to go over some of the ways to measure that today. And I have a PowerPoint that I put up on our page. I don't know why, but your guys' pictures are like right in the middle of my screen. So it's making it a little bit weird to look at my own screen. But that's okay. Let me figure this out and pull up that PowerPoint. Where's my data? Okay. Oh, all right. Sorry, guys. I thought that I had put that PowerPoint up yesterday. Let me just grab that right now. Let's see if I go here. Sorry. All right, got this. All right. Can you guys see the PowerPoint now? Oh, great. Okay, so I'm just going to walk through an example step by step on how we can calculate different measures of variability. I think it's really kind of hard to understand what they mean by looking at the formulas. Also, I thought, you know, your textbook was maybe a little too wordy and confusing when it came to some of these things. So hopefully if we just use some real examples, we can see how what these variables are doing. So what we're looking at here is abortion ratios. So how many abortions are performed in each state per 1,000 live births? So a couple of things when I'm just looking at this data that I first kind of think about. First of all, what is my N? So I have my N is 8. I know I'm looking at 8 different states. And then I think about, okay, the level of measurement of my independent variable. So this is a ratio. So again, my independent variable is ratio level. It's number of abortions per live births. So just a couple of things I think of. And I'm looking at, when I'm looking at the differences of across the states, I can see that there seems to be quite a bit of variability. But if I was just looking at a data set with, 1,000 respondents, it would be very hard to kind of see that by just looking. And that's why these measures of variability or measures of dispersion can be so useful. Okay, so just a review of what we were looking at before. I calculated the measures of central tendency as a starting place for this data. And so you can see that I calculated the mean and I calculated the median. And you can see that there's a bit of difference between the mean and the median in this particular example. So now we're going to move on to the measures of dispersion. I talked about this a little bit in the last video, but one of the most simple ways to begin to talk about how our data is dispersed is the range. So just looking at what's the difference between the maximum value for that variable and the minimum value of that variable. So if I were just to rank order the states based on their abortion ratios, taking the state with the highest rate of abortions and the lowest rate of the abortions, that would be giving me my range. So you can see in this example that the range is 423, which seems quite big. Of course, what's big or small, it's all depending on what is the actual value of that variable. So how we can talk about it here is that's 423 abortions. Another way to talk about it is through the interquartile range. So again, this begins with us rank ordering the observations, and then we're just dividing it into 4 equal parts. So the first quarter the first quarter becomes the first quarter becomes the first quartile, then the second, then the middle 2 quarters are the second, and then the third. And then the interquartile range is taking kind of the difference between the first and the third quartile. So
I just want to ask you a question.
Okay, what's the question?
Could I have the cookie?
Yeah, ask your daddy.
Do you know what kind of cookie?
Okay. What?
It's a fortune.
Okay. Sorry about that. I thought I locked my door. Okay, so because this is very similar to when you're calculating your median, if the quartile ranges fall between values because of your number of observations, then you just take the difference between the two. So in this particular example, I'm just taking, I'm adding 129 plus 155 and dividing by 2 to find that first quartile number. Some of you, if you've taken statistics, there's like a much more complicated way that you can calculate an interquartile range, which I've put on the next slide. So I just put that there in case anybody cares, but I don't expect that you figure that out for this course. But this is the formula if you want to calculate the interquartile range in a more precise manner. Okay, But I think really when it comes to measures of dispersion and variability, really what is one of the best ways to talk about it is the standard deviation. And that's why I want to go over how to calculate standard deviation by hand. So you can use statistical programs to get the standard deviation. You can use, spreadsheet formulas in Excel, etc. You can use your calculator. But when we go through and we do it by hand, you can really see kind of what the measurement means. So what we do in order to calculate the standard deviation. Look, this is my class. Boss. See? I know Daddy's not the boss, but he is right now. Say hi to my class.
Hi.
Okay, say bye.
Bye.
Okay. Sorry. It's tough around here lately. Okay, so, all right, here we are. We have our variables, our abortion rates. We've already calculated our mean. So our mean is 221. So you'll remember that we already calculated that. So the first step in calculating our standard deviation is to take our deviation from the mean. So basically, it's very simple. All you do is you take the ratio rate of each state and subtract the mean from that. So that's what you're seeing in the second column, deviations from the mean. You're seeing I took the actual value and subtracted the mean from that. The next step number 2, is you square those deviations. So you just multiply them upon themselves. So for instance, negative 220.1 times negative 220.1, that gives us 48,444.001. All right, you guys, are you following me with those steps so far? Thumbs up. Okay. So
I'm like really, really bad at math, but this is all explained in the book, right? From what I was reading, like step by step.
It should be. I thought it's a little bit, a tiny bit confusing in the book. They made it sound a little harder than it was. But yes, it's in the book. And obviously I'm going to put this on our on-course site as well, Mariana. And I have a couple other examples too.
Thanks. I promise I'm listening. It just like, for me to actually write it out and do it just takes me a long time. Yeah, it's a good time.
Yep. So we squared all those deviations from the mean. Then your next step is add those all together. So you're totaling your squared deviations. And that's how I get the number on the big number on the bottom, 131,670 plus 4, is just adding that whole column of the squared deviations together. Okay, so this is again where I said that they use the formulas in the book, and it looks a little bit confusing. But what you've already done so far is you guys have done the top part of the formula. It's showing you that the variance, that symbol is showing you that that's the sum of each value minus the mean squared. So what we just did together was the whole part of that, the whole top part of that equation. So the only thing left to do to calculate your variance is to divide by n. So n, of course, is your number of observations. It's also, if you're using a sample, statisticians have decided that it's more accurate to use an n minus 1. So you're either going to use n if you're not using a sample, if you have your whole population of interest, or n minus 1 if using a sample. So for this particular example, because I had a sample of states, I divided my total sum of squared deviations by 7, 8 minus 1. So you'll see there I have that 131,670 divided by 7 gives me 18,810.1. That number is my variance, which in itself is a measure of dispersion. However, it's not as useful, to me at least, a measure of dispersion as our standard deviation. So, sorry, where am I not? So, okay, so in order to get the standard deviation, all you do is you take the square root of the variance. So you can see that when you take the square root of the variance in this example, that you get 137.1. So what's very intuitive about the standard deviation is that it's in the same units of analysis as the variable that you're looking at. So I can look at that 137 and I could say that, you know, the standard deviation is 137 abortions. So let's go a little further into what that means. I can't see you guys anymore. Let me see if I can get you somehow. So just definitely, I can't see you. So if you have questions, just please chime in. Okay, so again, just to reiterate, the variance is used in different statistical applications, but the standard deviation is sometimes more useful, again, because it's in the same units as your mean, meaning the same units as your variable. Also, another reason that we speak about standard deviation is in its relationship to the normal distribution. And this is discussed in your textbook as well. But if our data is distributed normally, which is a statistical term, it means that it's going to be in the shape of a bell distribution, which is what you're looking at your screen right now. So if we were thinking about, thinking about this in terms of test scores for a class, if they were normally distributed, we'd have most people falling in the middle. You could see this example, maybe if we're saying the middle is a C, and then there's a big group of B's and D's, but we would have a smaller proportion of people getting A's and F's if the grades were normally distributed. You can also see that in a normal distribution, the mean, median, and mode are all the same value. So just thinking back to our abortion ratio example, we saw that the mean and the median were not the same value. So again, that makes us think that our data is potentially not normally distributed. But if the data is normally distributed, then 65% of the observations, meaning your actual data set, will fall within one standard deviation of the mean. So one plus one standard deviation from the mean and minus one deviation from the mean. And then 95% of observations will fall within 2 standard deviations of the mean. So that's what this bell curve is showing. So a way to think about it with this actual data is you can, really take the mean observation and then, add 1 standard deviation, 2 standard deviations. And sometimes you'll do that and you'll see that that it's fallen completely out of the actual range of your data. So that also gives you some clues about if your data is like leaning to the left, if there's outliers to the left, outliers to the right. So it also can help you talk about how and why your data is not normally distributed. So when we're interpreting our standard deviation for assignment 2, these are some of the things that we're going to want to think about. Okay, so I'm going to post some videos. I'm not going to go into it now, but I'll also post some videos if you guys want to be creating your own graphs for your final paper. So I will do that at a later date. But if you wanted to do, for instance, on this screen, we're looking at a box plot that's showing us with the whiskers of the box plot, it's showing us the range. The box is showing you that interquartile, those interquartile numbers, and then the line in the middle is showing the median. So we can see through this type of graph is another way to look at how our data is distributed. So I can post that online as well. So just to kind of get us started, I was just going to show kind of one more example that if people wanted to practice, that you could look at on your own. So again, a first important step is to look at our number of observations. Again, in this example, our unit of analysis is countries, and we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 countries. Our independent, or whichever variable we're looking at here, is death rate from firearms, deaths per 1,000th of the population. So again, another ratio level variable. Sorry, where was I going with that? Sorry. What I wanted to make a point of too is, when we're thinking of something like calculating the mean and then calculating the standard deviation, it's only going to be relevant for ratio level variables or interval level variables where you have a scale. If it's a nominal level variable, it doesn't really make sense to talk about what's the middle value and how is our data dispersed around the middle. So just think about that for assignment 2 when you're calculating these statistics. You're going to want to choose variables that are either interval or, even better, probably ratio level of measurement. Okay, so on the next page, I have the answers for this. So if you wanted extra practice, I'll put this on our page and you can kind of go through and calculate the standard deviation. So again, the first step would be to calculate the mean. Step 2 is to then take every value and subtract the mean from that value. Step 3 is to take all those deviations from the mean and square them. Step 4, add together all those squared deviations. And then step 5, divide by the number of observations minus 1, again, because we have a sample of countries. So I would take that total sum of squared deviations and divide by 10. That number, after I do that, is my variance. And then I take the square root of my variance to find my standard deviation. So again, those are the different steps that you're going to want to walk through. Okay, so let me see, 1 second, guys. Is everyone with me? Does that make sense? Okay, awesome. I just want to do one more thing. I want to show you how you could do this in an Excel spreadsheet. That way, when you're doing it with your own data, if you have a lot of observations, it's a way that will be able to save you some time, but it will still allow you, it will still let you to be able to show your work. So let me share the screen again. Okay, let's see. Okay, so I'm going to pull up that data set that we're working with for the homework this week. Sorry, I changed around our on-course page to try to make it easier, and now I'm confusing myself. Okay, so I'm going to pull up that 36 country data set in Excel. Okay. So first of all, I want to choose a variable in which it would be relevant to do calculate a standard deviation. So I would want nothing nominal. I would want something ratio level data. So I'm going to take the or ordinal. I'm going to take the press freedom scores, and I'm going to calculate a standard deviation. I'm just going to start a new sheet to make it easier. Okay, wait. Okay, so I have all my variables here. This is the measure of press freedom. Just making sure I copied it correctly. I have 36, so I have 36 observations for those 36 countries. The first thing I'm going to do is I want to calculate my mean. So I'm just going to auto sum these variables by hitting this blue auto sum button at the top. And then I scroll down, and this number at the bottom is that auto sum. So I'm going to click on that, and I'm going to go up into my formula key, and I'm going to divide by 36, my number of observations. And so then I see that my mean is 39.25. So then my first step for calculating my standard deviation is I'm going to take my observation. I'm going to go back to my formula bar, and I'm going to subtract the mean. And of course, I already forgot what it is. 38 point, I'm going to round up to 38.7. This equals, all right, so I do this equals this minus 38.7. Why didn't that work? Oh, wait, I don't think, okay, sorry.
You have a minus sign in the 21.
Oh, thank you, that's problematic. Okay,
No
thank
problem.
you, Marianne. All right, so we'll do, sorry to try again, this equals this minus my mean. All right, good. So then I can just copy my formula and paste it for all my observations. So you can see that it subtracted the mean for each of those. So now what I'm going to do is square my deviations. So I'm going to go here, and this, I'm going to do equals this times itself, squaring it, and hitting return there. That's my squared deviation. I'm going to copy my formula and paste it down through my observations. Okay, and then the next step I'm going to do again is I'm going to sum those squared deviations. So hitting my auto sum key again, and here is this number right here is what I call my total sum of squares. So the next step then is to calculate my variance. So I'm going to divide by n minus 1. So I'm going to take my total sum of squares and take my total sum of squares and divide by 35. And then this number I have right here is my variance. And then in order to get my standard deviation, the final step is that I want to take the square root of my variance. I think it's SQR. Is that true? Let's see. No, that's not right. Sorry. There, I'm just trying to find the formula for square root. Sorry, guys. I thought it was equal. I thought it was SQR.
Question. If we were like, I know we can do it by hand, but if we were at school and had like the programs that work for like the numbers that you had talked about, like the ones the school own, would they do this stuff automatically?
Yes. So I want you to do it by hand just for the purposes of assignment 2, just because I think it's a good way to understand kind of what the variable actually is. But yes, you can for the purposes of your final paper, you can definitely have shortcuts for this. And I can actually, I'll actually post videos too. There's like shortcuts, even if you don't have the fancy statistical software, you can use the shortcuts in Excel, and there's shortcuts in probably like in Google Sheets as well. So I can look those up and definitely send you guys the shortcuts for the purposes of if you want to calculate any of these for your final papers. All right, does anyone know this code for square root in Excel? All right, so anyway, wait, let me just look it up real quick. Oh, SQRT. Sorry about that. All right, let's go back to our data set. And then we sell SQRT equals SQRT and this. Okay, sorry. Like this? Oh, shoot. All right. Oh my goodness, sorry guys. This is embarrassing. Okay. I think it's just because I have a space. 1 second. Okay, so the square root is 24.42. So just one thing, final thing I wanted to point out is that, again, it's in the same units of analysis as our mean. So if you are calculating your square root and it's a number that's just either much too big or much too small to make sense given your data, then you know that obviously you've made a miscalculation along the way. So for this data, again, our mean was 39.25. So if this press freedom variable was equally distributed, we know that that 65% of the observations would fall between one standard deviation of the mean. So 39 plus 24, 39 minus 24. So definitely this number of 24, just kind of giving a rough look at the data, it seems to make sense. It wouldn't make me think that we made any mistakes calculating our standard deviation. Okay. So that was, those were the examples that I wanted to walk through for today. Do you guys feel confident that you could calculate calculate those standard deviations for this week's homework and for assignment 2. Feel pretty good about that. Okay. Okay, that's great. So I guess we'll just end there. And if anyone has, as you try the homework assignments, if you find yourself having any trouble, just reach out to me, and we can, set up a meeting to work on it in a small group or individually. Okay, sound good? All right. Thank you guys for joining me, and I will talk to you soon. Bye.
Thank you.
Thank you.